Hey everybody, welcome to my third video on trigonometric integrals, and in this video I'm going over an example where we need to use U substitution and trig identities. So take a look at this example and notice how there is an exponent on top of both trig functions. And this is what a typical example looks like where you need to use trig identities. And the idea is that you want to look for the trig function with the odd exponent. And if you don't have an odd exponent, I'll go over an example like that in my next video, but we want to look for the trig function with the odd exponent. So notice how this cosine has an odd exponent of 3. So the idea is that you want to separate this. You want to take 1 away. So if we take 1 cosine away, and we had 3 to start with, so that means there's 2 left over. So we have the cosine squared of x, because there was 2 left over, multiplied by the cosine of x, and that will give us our cosine cubed. So we separated and we took 1 cosine away, and the rest of the integral stays the same. We have our dx and we have our sine to the 4th of x. And after you separate the cosine, this is where we need to use our trig identities. And if any of you forget your trig identities, I'll write it on the top right hand part of the screen so you remember. And this is probably the most common trig identity. It's the sine squared of x plus the cosine squared of x is equal to 1. And if we subtract the sine squared of x from both sides, you could rewrite this as the cosine squared of x is equal to the 1 minus the sine squared of x. So notice how we have a cosine squared of x in our integral. And we know that the cosine squared of x is equal to 1 minus the sine squared of x. So I'm going to replace this cosine squared of x with 1 minus the sine squared of x. And the rest of our integral stays the same. We have our sine to the 4th of x, and we still have our cosine of x on the right, and our dx. And now this becomes an example where we can use U substitution. If we pick our U to be the sine of x, so our U is equal to the sine of x, and then our du is going to be the derivative of the sine of x. The derivative of the sine is the cosine of x, and we can't forget to put our dx. And notice how in our integral we have a cosine of x dx, and our du is also equal to the cosine of x dx. So this is a good indication that we're on the right track, and this is why we separated this cosine of x dx. So we have something that is exactly equal to du. So now it's fairly easy to plug into our integral everything in terms of u. So let's do that right now. Let's plug everything in terms of u. And we know our u is equal to the sine of x. So instead of sine to the 4th, we're going to have u to the 4th. And instead of 1 minus sine squared, we have 1 minus u squared. And our cosine of x dx is equal to du. So instead of the cosine of x dx, we're just going to have a du. And now this has become a pretty straightforward integral. If we distribute, and we can distribute this u to the 4th with the 1 and the u squared. So this integral becomes u to the 4th times 1, which is just u to the 4th, and u to the 4th minus negative u squared is equal to negative u to the 6th, and this is all being multiplied by du. And now we are ready to integrate. If we integrate this, we just add 1 to the exponent. So u to the 4th just becomes u to the 5th, and you always divide by the same. So you divide by 5, and this is being subtracted by the integral of u to the 6th. So we just add 1 to the exponent, This becomes u to the 7th all over 7. And we can't forget to add our constant plus c. So now we have completely integrated, but our final answer should always be in terms of x, not in terms of u. So let's plug everything back in for u in terms of x. So instead of u to the 5th, well, let me go back and see what our u is. Our u is equal to the sine of x. So instead of u to the 5th, it's going to be the sine of x to the 5th, and this is being divided by 5, and this is being subtracted from u to the 7th. So instead of u to the 7th, we're going to have the sine of x to the 7th, and this is being divided by 7, and once again we can't forget about our constant plus c. So this is our final answer of our solution. I hope this gave you a better idea on solving trigonometric integrals. This is a fairly complicated example, so don't worry if you need to watch this video a few more times. I will be making many more videos on trig integrals in the future, so stay tuned, and I really hope you're enjoying these, and I will see you in my next one.